Hi, students. In this lecture, I am going to discuss problems based on pressure and force. Let us see first one. Let's see the question. A glass full of water has a bottom of area 20 centimeters square, top of area 20 centimeters square, height 20 centimeter, and volume half a liter. Find the force exerted by the water on the bottom. Considering the equilibrium of water, find the resultant force exerted by the sides of the glass on the water. Given pressure of atmosphere, density of water, and G value. Let us see first given diagram. So given height 20 for top and bottom area 20 centimeters square. Let us see how to start. So first we have to find force exerted by water on the bottom. Let us see. Right, first make the diagram. See given diagram. Right, height is given 20 centimeter. Right, the first one, force exerted by water at the bottom. So at the bottom, we have to find force by liquid. So in that, first we have to focus what is the pressure at that point. So coming to pressure at that point, you can see here pressure equal to pressure of atmosphere, that is P naught. Now this depth equal to H. So pressure equal to pressure at the bottom. I'm taking suffix B for bottom. That is equal to P naught plus H rho G. Okay. If we know this value into the corresponding area, okay, let us see what we get. P naught, and that value given us 10 power 5. It is given 10 power 5 H rho G. See what the H given? 20 centimeter, that is 0.2 meter. Rho, density of water is 1000. G value 10. See how much we get. This is 2 10 power 3, 2 10 power 3, and this is now 10 power 5. That means its value will be, so pressure equal to, I can write it as 102 into 10 power 3. Units are Pascal. Cross check once. This is a 2 10 power 3, and this is a 100 10 power 3. Okay. So 102 into 10 power 3. Right. This is now pressure at this surface. Right. So force on the base by liquid, that is equal to pressure at the bottom into area. So what is now pressure? Pressure is now 102 into 10 power 3. 102 into 10 power 3. Pressure. Area is now, area given. Area is given. See how much given area. So it is given 20 centimeter square. Area is given 20 centimeter square. If you convert into meter square, it is 20 10 power minus 4 meter square. Okay, because centimeter means 10 power minus 2. 10 power minus 2 whole square. 10 power minus 4. So now take that here. It is 20 into 10 power minus 4 meter square. This is now Newton. Now see calculation. So 10 and 10 power minus 4, 10 power 3 gets cancelled. Remaining is now 2 into 102. That is 204 Newton. This is a force by liquid on the bottom of the vessel. Okay. That's the first part we have to calculate. Right. Now focus the second part. Focus second part. Consider the equilibrium of water. So here water is in equilibrium. Therefore, net force on water must be zero, right? Find the resultant force exerted by the sides of the glass. So we have learned that liquid takes the shape of the vessel. That means now shape of the liquid is shape of the vessel. So this is now shape of the liquid. Okay. Right. Now focus. Free body diagram for liquid. Force by the bottom of the vessel on liquid. That is vertically upwards. I am taking same rotation. That is FB. That is upwards. Okay. This is force by bottom of the vessel on liquid upwards. EMG. EMG downwards. Next. Force because of pressure of atmosphere. That is P naught into A. Right. Next. Remaining is by curved part. So by curved part, force. Take it as FC by curved part. And this you can see force here. Force by the container or by the walls on liquid. It is always normal to the contact surface. It is now like this. If you are focusing here at this point, it will be like this. It is always normal to the contact. It is like this. And by symmetry, if you observe, taking components horizontal and vertical. Components horizontal and vertical. So these are horizontal components gets cancelled. Okay. Remaining is only along vertical. So here vertical down and here vertically up. Okay. So net value may be vertically up or vertically down. And that we have to decide now. Okay. Now see what we can do here. Weight equal to mg and mass given it is a half a liter volume, half liter, and we are knowing that 1 liter is equal to 10 power minus 3 meter cube. We are knowing that 1 liter is equal to 10 power minus 3 meter cube. It is given half a liter. So half liter means this is a half into 10 power minus 3 meter cube. That is volume of liquid into density. Density of water is 1000. This gives us mass of water into G. This is giving us weight of liquid. See how much? 10 power minus 3, 10 power 3 gets cancelled. 10 by 2, that is 5. It is a 5 Newton. That is downwards. And you can see here this force is 2 not 4 upwards. Okay. Next, P naught A. See what is the value of P naught A. P naught 10 power 5. Cross section area 20 10 power minus 4. 20 10 power minus 4. Okay. 10 power 5 and this gets cancelled. Remaining is now 10 and here 20. This is a 200 Newton. Okay. So P naught A 200 that is downwards. mg 5 that is downwards. So 205 that is downwards. But from the bottom force by bottom of the vessel on liquid force is 204 upwards. I'm drawing here. P naught A 200. Weight of liquid 5. So 205 downwards. By bottom of the vessel on the liquid 204. But we are knowing that liquid is in equilibrium. That means net force on that should be 0. When this is 205, this is 204, then by curved part, force must be vertically upwards so that sum is balancing this value. So from this we can say that by curved part, force must be vertically upwards and its magnitude is this is 205, this is 204. So this must be equal to 1 Newton. It is vertically upwards. Okay. So like this, we can calculate force by the vessel on liquid by the curved part. Okay. So I hope you got clarity. Let us see next one. Right, see the question given. A tube of cross section 1 centimeter square is attached to the top of a vessel 1 centimeter high and cross section area 100 centimeter square. You can see here height is 1 centimeter. Its a cross section area is now 100 centimeter square. Water is filled up to a height of 100 centimeter as shown. This is 99 and this is 1. Total is 100. Okay. And G 10 meter per second square. Calculate the force exerted by the liquid on the bottom of the vessel. So almost same kind of question. Let us see how to start. Right, first make the given diagram. Given this is a tube. And its a cross section is now 1 centimeter square. This is attached to other one and this has a cross section. And this has a cross section that is given as 100 centimeter square cross section area of the bottom and this a height equal to 1 centimeter. And liquid is filled up to a height of 100 centimeter. This is now liquid. And this height is 99 centimeter. Right? Calculate force exerted by the liquid on the bottom of the vessel. Force exerted by the liquid on the bottom of the vessel. Okay. Then see how to calculate. So we have to calculate now at the bottom what is pressure. Okay. If we know that, then that pressure into the corresponding area. Okay. So area is known. So focus now what is pressure. Let us take here neglect pressure of atmosphere. P naught is neglected. Then see at the bottom pressure equal to pressure at the bottom equal to H rho g. H value 1 because 1 centimeter plus 99 that is 1 meter. H rho value density of water is 1000. H rho g. G value 10. This is now 10 power 4. 10 power 4 Pascal. Okay. Or you can say Newton per meter square. Now coming to area. So area is known. So force on the base by the liquid is equal to, it is equal to 10 power 4. That is the pressure. Area is now 100 centimeter square. Convert into meter square. Okay. So into 10 power minus 4. Okay. 10 power minus 4 Newton. So answer is now 10 power 4, 10 power minus 4. It is 100 Newton. Okay. So this is now force acting on the base by the liquid. Okay. Now focus here one more thing. That is, see what is weight of the liquid. Let us now calculate weight of the liquid. Weight W equal to mg. Okay. Coming to mass. Coming to mass, we have to focus first of all what is volume of liquid. Okay. So coming to volume of liquid. Focus now this part of the volume. Height equal to 1. Area is 100. So volume is now 1 into 100. Okay. That is Cc plus coming to this volume. Focus now this part of the volume. Area equal to 1. Height equal to 99. So 1 into 99. So 199 centimeter cube. So convert that into meter cube. That is 10 power minus 6. Okay. See once again. So this area 100 centimeter square into 1. So 100 centimeter cube cc. This is now 99 cc. Converting into meter cube. So 10 power minus 6 meter cube. This is volume. Volume into density. Density of water is 1000. So this gives mass of water into G. Okay. That gives us weight of liquid. See how much we get. 10 power 3, 1, 10 power 4. Remaining here 10 power minus 2. This is 199 into 10 power minus 2 Newton. Or it is 1.99 Newton. This is weight of the liquid. And if you see carefully, force by the liquid on the bottom of the vessel. How much? 100 Newton. But its weight is only 1.99 Newton. Okay. Now see carefully. Free body diagram for the liquid. And we are knowing that liquid takes now shape of the vessel. So here see what I am doing. I am taking now shape of the liquid, not vessel. And shape of the vessel and shape of liquid both are same. Okay. So once again, same diagram. It is same diagram. Remember, this is now liquid, not vessel, because both shapes are same. Okay. So here we have taken P naught is neglected. So remaining is now. See, free body diagram for liquid. Liquid is now in equilibrium. So net force on the liquid must be zero. So one is weight mg downwards, which is 1.99. Next, force by bottom of the vessel on the liquid upwards, which is equal to 100 Newton. Okay. Next, so this is a force by bottom of the vessel. Now focus by the vessel here. It is horizontal in all directions, horizontal. Okay. By this part of the vessel on liquid, force is only along horizontal. And by symmetry, they will cancel. And coming to here, and by this part of the vessel, force is only along horizontal. And again, by symmetry, they get cancelled, right? Now remaining is only by this part of the vessel. I am marking here by a yellow color. By this part of the vessel on liquid, force will be vertically downwards. Force will be vertically downwards. So we have discussed that by the vessel, force on the liquid is always normal to contact. It is always normal to contact. It will be vertically downwards. I'm taking it as vertical means F suffix V. Okay. So by the vessel along vertical, it is downwards plus that value. Now see carefully free body diagram. Weight mg downwards. By the vessel along vertical, it is Fv downwards. By the bottom, it is upwards. Net equal to zero because liquid is in equilibrium. Okay. Now from this we can say force by the vessel along vertical, it is downwards, that is equal to 100 minus 1.99. Okay. And see how much we get. It is equal to 98.01 Newton. Okay. Means if they ask, find the force by the vessel on the liquid along vertical. Okay. Means by this part. Okay. That is 98.01. By the vessel at the bottom 100. Right. Like this, they can ask separately by the bottom how much. By this part of the vessel, how much? It is 98.01. So if you observe the previous problem and this problem, both are almost same questions. Okay. Even in that we have taken liquid is in equilibrium. So force by bottom of the vessel, force by curved part. In that way, we got calculation for by curved part of the vessel on the liquid. Force how much is acting. So both are same kind of problems. So I hope you got a clarity.